Hello everyone, this is a class of ECE 341, the probability and the random process for engineering. Welcome. Today is the first day of this semester, and this is the first class of our course after the winter break. Actually, we just had a pretty warm winter break this year, right? This winter is quite warm, and but now it's cold, and the first week of this semester will be really cold. But fortunately, we stay at home. We will keep online teaching at least the first 2 weeks, depending on the COVID cases is not so it's still increasing rapidly. Today we will go over the syllabus and then discuss some basic concept of this course. Okay, let me go to here. This is the blackboard. So you should know how to use the blackboard, right? We have all the information here. You can find everything from blackboard, and I will post everything in the blackboard. Now the first one is the syllabus. This is the name of the course. It is a 3 credit hour course, and instructor is me. This is me. My name is Ning Jin. Yeah, you can call me Ning, or Jin is also fine, but the first name is Ning. Alright. And the lecture time, we have lecture time Monday, Wednesday, Friday from 3 to 3:50 p.m. But now, we are working online, so you can watch the class anytime. I recorded these lectures and posted in YouTube, so you can watch it anytime. But we will have tests like exam. We will have 1, 2, 3 exams, 2 midterm, 1 final, and those exams you have to attend the exam on this time, one of it. For example, some Monday we have midterm, then you need to take the midterm at this time, 3 p.m. to 3:50 p.m. Alright, yeah. And office hour, that will be in Zoom meeting. I didn't set up the time right now. After I make the time, I will put it here, and I will also send the announcement to let you know when is our office hour. So the thing, you can watch the recorded videos to learn the lecture, and if you have problem, you can attend the Zoom meeting, then we can discuss what's wrong. Alright, and not just something wrong, anything related to the class, you can talk to me during the Zoom meeting. Okay, office hours. And of course you can also email me, and I will set up a Piazza discussion board that you can also put your question in the Piazza. Okay, so this is generally. Then for the class, prerequisite is grade C or better in Math 210, that is Calculus 3. This is requirement of the department, but in my sense the calculus might be 1 is enough. Yeah, some integral and integration. The derivative and integration, right? Calculus 1, calculus 2, 1 and 2, that will be enough. And also we need some linear algebra and MATLAB. For some part of this course, we need to handle 10 or not 10, more than 10 numbers, 100 numbers, 1,000 numbers. You do some calculation on those numbers, then computer is necessary. If you want to calculate by your hand, several tens numbers, do some calculation on those numbers, that is cost too much time. So use computer, and then we most convenient one is MATLAB. And for MATLAB, you need matrix vectors, so you need some linear algebra, right? Okay, Then the textbook. This is textbook. You can find the paper, the paper, the book in paper from the bookstore of our university. You can also find some like a PDF file of this book online. I know some website you can find it, like which one? I think, yeah, we have this one, textbook. This website, the name is Library Genesis. Yeah, you search, you look at this, go to this website, then you search, you put the book name and search the name. You can find like a PDF file of that book. Yeah. Alright, I go back to it. Yeah, this is textbook. And here I said it's a 3rd edition. If you want, you can also use some early edition. The 2nd edition also fine. The difference is I will take the homework from this book. Pick the homework from this book. If you use different version, the homework problems might be different. So I pick the problems here from this book. Alright. Then what we will study in this course, basically this is probability is a very important part of our study. Yeah. And we need in this course we need to learn some basic thing about it. And here are topics. Here I listed. Here are the topics here. All these topics, they are separated as 3 parts. The first part is probability theory. Probability theory is some basic things like random experiment, sample space, events, probability, and its axioms, and so on. Some formulas, things like that. And the second part is a statistic method. Statistic method, there are some method to do some calculate to find some important information from the data. So here the probability is probability theory is a fundamental. Then statistic method is kind of application, right? Application method. And also we need to know the stochastic process. Also we call it as a random process. You can think this is a sequence, a process of some probability things. Okay, I will explain it later. And then here assessment, we have 4 parts: 1 homework, and midterm 1, midterm 2, and final exam. So totally I will calculate the final grade based on these 4. The homeworks, is 30%. Every week, almost every week. The first week we have, almost every week we have homework. Okay, weekly. And then midterm 1, midterm 2. You see here in the topic I have part 1, part 2. So after we finish the first part, we will have midterm 1. After we finish the second part, we will have midterm 2. And then after we finish part 3, we'll have the final exam. Midterm 1 and the midterm 2, they are only cover the this part. The first like midterm 1 cover the probability part, and midterm 2 cover the statistic part, and then the final exam will cover the whole semester, not only just the part 3. Of course we need part 3 in the final exam, and we also cover part 1 and part 2. Okay, these are the exams. And then the grade. So that's normally, we have A, B, C, D, F, and we use the total grade. Over 90 90 over 90 is A, between 90 and 80, or not include 90, here should be 89. 80 to 89 should be B, and 70 to 79 will be C, then D, and then F if the grade is lower than 60. And then for the homework submission, for late submission, if you have some reason you cannot submit on time, you still can submit. Actually, you can submit anytime, but here I have some penalty. If it is late but before the solution is posted. Now every homework the solution will be posted after the due time. Usually you will have 1 day, at most 2 days. So that means if you late, it's not too much. Yeah, before the solution is posted, then you only lost 10%. But if you submit your homework after the solution is posted, then you will only have 60%, right? You are lost 40%. You are lost 40%. Yeah, like if the problem that homework totally is like 20 point, then you are lost 4 point, 8 point. If you the homework is like 100 point, then you are lost 40, right? Things like that. Yeah, this is this is the syllabus. It's a simple one, right? Any question? I don't. Yeah, if you have any question, we can discuss during the office hour, right? I said that we will have office hour. I will set up the office hour in these 2 days. Okay. Yeah. All right. Now let's go to the class. Yeah, we have time, right? Now I only use 12 minutes. So the class is 50 minutes, right? We still have like 40, almost 40 minutes, 30 some minutes. So we can discuss some basic thing about this course is here. Okay. All right. This is a ECE 341. This is the first lecture. We say this course is a probability and random process. Okay, so what is the meaning of these two things? Okay. Here we have 3 vocabularies. What is the meaning of them? The first one, what is a random one? What is a random one? The first one, we say random. What is the meaning of a random? Actually, it is a random experiment. Random experiment. What is random experiment? You should know what is experiment, right? We have some other different courses. You have experiment, like you build a circuit, then you give the input side, you give certain voltage, then the output side you will have another kind of voltage. That is a not random one. The same circuit with same input voltage, the output voltage will be a same one, right? No matter you do it, some other one do it, or you repeat do it, every time you will get same result. That is not random one. What is random one? If you see, I have this one. See what it is? I have 2 dice here, right? Okay. Now I do an experiment. I was rolling, and okay, see, I have 4 and 5. Okay, now we do the same thing. Same thing, right? We do the same thing. Same action. 3 and 6. That's a different. So this is kind of experiment. Every time you will have different answer, right? Different result. Nice. Different result. Right? Oh, this is a 2 and 5. Right? Every time you get something different, but you do the same thing, right? So this kind of experiment, we call it as a random experiment. So it has some features. First one, result will be more than one possible. I say possible, right? You have more than one possible of the result, not just one result. But of course, you have some more different possible result, but not everything. Like here, I have two dices. Then every dice, the largest number will be 6. You cannot get any like a 7 or 10. No, at most 6. Right? At most 6. 1 and 4. Right? And at least 1. You cannot have nothing or some negative value. Right? So we have a range. There is a how to say that? There is a set, which is a set of all possible result. All possible result. There's a set. So your result must be one of the result inside that site. Yeah, inside that site. Like here is our set is for dice there will be 1 to 6, right? 1 to 6. So that set is 1 to 6. You cannot have any result other than the number between 1 and 6. Right. Okay. C. Before you have the result, you do not know what will happen. Yeah, you cannot know. Like here, say, okay, what will result? Can you have a 1 or 2? No, you don't know. You just say, okay, no 1, no 2. I have 3 and 4, right? So before you do it, before you get the result, you have no idea about what will be the final result. But at least when you are done, when you get the result, when you have the result, that will be a, how to say, a fixed one. You know the meaning? Yeah, it's a fixed one. It won't be something else. Like you have, okay, I have 3 and 6, right? I cannot have like a 3.5. No, you cannot show. Okay, this is a 3 or 2. No, it is 3. Just 3. Nothing else. It is 3. This is a 6. Nothing else. It's a 6. They are fixed one. After you get it, you get some fixed. Yeah. All right. So this is I would say the basic feature of a random experiment. Actually, we have this kind of things like everywhere, every minute in our daily life. For example, you're walking, right? You're walking. You're step by step, you're walking. Okay, you'll say, what is the location for your next step? Your foot will step somewhere, right? But before you step on it, yeah, maybe a little bit left or maybe a bit right, right? Yeah, it's not uncertain. But when you step on it, okay, you have that. So you can think that is kind of random experiment, right? Yeah, maybe you one step you step more ahead or a little bit different, right? Yeah. And also like you take a bus, you go to the bus station. Maybe when you arrive, the bus also arrive. Now maybe you need to wait like 30 minutes for next bus. But before the bus coming, you do not know what will happen, right? So all these things you just observe. You look at your daily life. We have a lot of things looks like this. Random experiment. The result is uncertain, but they still have a set of possible results, right? It is not totally out of order. They have some restriction. Your result will be inside certain set, and usually you have more than one result in that set, and the result will be one of it. Before you get it, you do not know. Yeah, only if you get it, you know, okay, this is result. And you know, like for for example, the signal. You know the signal, right? In our electrical engineering, we need a lot of things related with signal, and signal is a kind of random thing. For example, I'm talking here, right? If you record my voice, there will be a signal. You will record a sequence of number. But before I speak out, what will be the next voice of me? Do you know that? No, even myself, I don't know what will be the next voice, right? Maybe I speak fast or slow, different pace, different volume. Yeah, before I give my sentence, no one know what will be next volume, next value. So a record of voice of some people, that is also kind of a random experiment. You can think every second you do an experiment, or not just second, this is continuously. You can think like every 1/10 of a second you record the volume, you record the sound, and every record, before you make the record, it is uncertain, maybe a little bit change, and after you record it, okay, okay, this is the voice, that one, just speak out, right? Okay, so that is of course that is a lot, not just one value. You need for voice, you need to record like every second. Usually I think every second there should be several thousand recorded values, right? So that is a process, random process. Random. You can also call this as a random signal, a sequence of values, a process of values. Is random. Yeah. Okay. Let's say random process. That will be a sequence of random value. I say random value. A sequence of random value, not just one. In a random experiment, you do one experiment, you get one result. If that result is a number, then you get number. Like I use dice, I get number. If I use like a coin, right? You throw a coin and see what will be the upside, maybe face, maybe tail. Then you have two words or two graphs, right? The tail and the face, two different graphs. Yeah. But if they are numbers, so usually we consider the random process. There should be some numbers, some values, a sequence of random values. That is random process. And you can also think they are the random signals. Random signals, a sequence of signals. Alright. Then 3. What is probability? Probability, you see, we say for random experiment, there is more than one possible result, and all these results they have a set, right? They have a set. All the results were inside that set. Then our problem is which result will happen with more chance, and some other result maybe happen. It's hard to be occurred. So their probability, or say the possible. You can say the possible. They say the number to measure the possible. It's a value. It's a number to measure the possible. The number to measure the possible. Like here, I have 2 dice. If I use one dice, I have 6 results. Then okay, I get 5. Then can you see? Next time you still get 5? No. So every time you have a chance to get 5, but that is just a chance. So we need a number to measure the chance. Some result maybe have more chance to happen. Some result maybe is hard to get that result. Okay. So we use a number to measure the possible. We call that number is a probability. Okay, so these are the basic concept related with these three. Okay, now we give a way to describe these by a more mathematical way. So we go back to the random experiment. For random experiment, we have several things. The first one, a single result. We call this a sample. That is a sample. Like if I use a dice, then we have 6 samples, right? Have dice, 6 different samples. They are 1, 2, 3, 4, 5, 6. We have 6 possible samples. Okay. So each is a sample. Each one is a sample. And secondly, we say we have a set, right? All possible results, that is a set. We call this set a name. We call it as a sample space, right? The set of all possible samples. Right. A single result is a sample. Now all the possible samples, we put them together. That is sample space. Let's show you this example. A dice. Usually we use a letter capital S for the sample space. So this for a dice, the sample space equal to 1, 2, 3, 4, 5, 6. I put them all together like this way. So this is a dice, the sample space of a dice. And we can also have like a coin. Then the sample space, we have face and a tail, right? Face and the tail. And what else can we have? Like the temperature of, okay, just next day, tomorrow. We do not know, but I can say it is as low as -5 to as high as like 40, right? Am I right? Yeah, tomorrow I don't think the temperature will be higher than 40 or lower than -5. Some value between these. So this is this interval between -5 and 40. Yeah. Okay. So this is also an example. And here you can see the sample space sometimes is not uniquely. Like here, I say tomorrow's temperature will be, the sample space will be this interval. But maybe if you change this 40 to 50, it's also fine, right? No problem. Yeah. And also here, a dice, the sample space 1, 2, 3, 4, 5, 6. I can also put a 7 here. But we have the probability, right? We have another thing is probability. Then for that 7, the probability should be 0. That means it's impossible, right? The chance to get that 7 is 0. Yeah, you can add more numbers in the sample space, but those numbers, those results, they are 0 possibility. They have no chance to get it. You also find. But usually we give the sample space only with numbers with possible with some possible, right? They still have some chance to get it. Then you put it in the sample space, right? So this is they are the sample space. All right. Now the third thing, the event. What is the event? That is a subset of sample space. I would say part. That means part of the sample space. Part of it. I use an example to explain it. Example: a dice. A dice has sample space which is 1, 2, 3, 4, 5, and event, let's say small. I use event 1. It is 1 and 2. If you get the result 1 and 2, let's say you get small. You get large, event large, that is 5 and 6. And you have the event odd, that is 3, odd, okay, 1, 3, and 5. Right, the event. You can have different event. Event will be a subset or part of the sample space. Right, whole sample space is here, and you have some part of it. Right, part of it. I still use this notation. I put the result here, and we use to blank to cover to close to them. Right, cross them. And here E1, it is just a name. You can use E1 for this event. You can also use a P1 for this event, or just a P for this event. Any letter. You can put any letter, any number. This is just a name of this event. Okay. Yeah, here I have 3 events. I call them E1, E2, and E3. If you want, you can also call them like a B1, B2, B3. Doesn't matter. Yeah. Okay. They are the event. And also like the temperature. The temperature tomorrow. We say tomorrow may be colder than today. I say it's colder. They have that is a E. That's here. I use anyway. I use a K, for example, K1. That is from -5 to here, right? Say the whole sample space is -5 to 40. If it is a -5 to like 9, I say this is cold. If it is high, say K2, it is from 30 to 40. That's higher. That is high. All right, and between them is a middle, right? Just middle. K3 between them from 9 to 30. Okay, that is the middle. Oh, this is the 10. Okay, the 10 to 29. 10 to 29. Okay, 10 to 29. Okay. So you have 3 different events. Each event is a part of the sample space. Right, whole sample space is a interval between -5 to 40. Right, -5 to 40, and you separate. Here's a 10. Here's a 30. Then this is a middle. This is a lower. This is a higher. Right, you have three different events. Right. Yeah. So they are the event. Okay, these are the event. Okay, Then the fourth one, what is the probability? What is probability? Yeah, this is this is the most kernel concept of this course. What is the probability? Probability is a chance for something happen, right? Like here I use one. Okay, just use one dice. I just use one dice. You can have one of the result. Now, how can you know the chance of this number 5? What is the chance you can get number 5? You can think, okay, they have 6 chance, so 1 of 6, right? You can think the chance is 1 of 6 chance, 1 over 6, 1 out of 6 as a chance. But maybe the dice is not a fair one, right? Maybe one side is more heavy, like maybe the 6 side is more heavy, so you have more chance 6 is is in the below, and then you have 1 in the top, so you have more chance to get 1 if this side is more heavy, right? The 6 side is more heavy, then you have more chance to get 1, right? Make sense? So I would say every single dice, suppose the quality is not uniformly, every dice, every number will have different chance. Make sense? And now it is fine because we created introductionally, so everyone they have the same qualities, and you can always think each side you have same chance. But if you think you make it use different material by your hand, then the chance for every numbers will be different. Then for these dice, what is the probability of these 6 numbers? How can you get it? Okay, I will say we have method. You try like 10 times or 100 times or 1,000 times, and then you take account how many 1s, how many 2s, how many 3s. Then you know, okay, that will give you the probability. Make sense? Okay, so the probability is a kind of a feature. You cannot find it directly. You need to find it, use certain, repeat it. You need to repeat the experiment with more time. Then you can see what is the probability behind it. So this is kind of number behind this experiment, like behind the dice. It is a number. You can usually we use a percentage, like 1%, 2%, 100%. That means 100%. That means always happen. 0%. That means never happen. And some percentage between 0 and 100, there will be a certain chance, right? So we use that for the chance, and you can get it by a lot of experiment. You make a record, and then you check which result happen more times, which result happen less times. So it will be things like that. A number, I say p, a number p. The value will be between 0 and 1, or you can say 0% to 100%. Right, same thing, right? The 1 is 100%. It's a number between 0 and 1. You are not use the chance, like you have 200% possible, or like -5% of the possible. No, that doesn't make sense, right? So for the probability, there will be a number. The number must be between 0 and 1. 0 and 1. And if we repeat the experiment a lot of times, we can then estimate the value of p. Yeah, it's a kind of estimate. You can estimate. We can estimate the value of p. Like this one, if we try, like for example, we try 600 times, then most possibly it should be like that. You will have around like 101 to 106 4 106. You know, each side you have about 100 times totally if you try 600 times, but not exactly same. Maybe like 3 you have 105 times result, and this 5 you have like only have 85 result out of totally 600 result, right? So that it will be kind of estimate. Your estimate, your check the number, something happen, right? Yeah, depends which one. I say some event. The event happen. Event happen. The number of the total experiment. This one will close to the probability of that event, right? That event, like I say, the 5 occurs, or I say even occurs. Like we have the odd or large or like even a different event. So the probability of that event. So we have this. You have this. So what is the probability? It is a number which can measure the possible of that event happen or not happen, right? And how can you get that number? You need to do experiment, then you check the the rate of that event happen, right? That is give you almost close to the probability of that event. Of course, you do more experiment, then you will have more accurate result. Yeah, things like that. All right. Okay. I think these are the all I want to give you today, and we still have 8 minutes. Okay, we can do a little bit in MATLAB. As I told, we can use MATLAB, right? MATLAB. Actually, not only MATLAB, any kind of software, C or Java or Python or something, you can use anyone. Yeah, but MATLAB is the most convenient for us. We do not need to pay. Did I click on it? Yeah, we do not need to pay more time on the coding. We can just because it provide. Oh, I click 2 times. Sorry, a little bit slow. Click 2 times. I need close one. Okay. In MATLAB, there's a function random, or run, just run. They have a run. You can see help run. This one. A random function will give us random numbers. The number will be matrix with random entries. Choose from a uniform distribution on the interval 0 to 1. So what is the result? Yeah, distribution, we will discuss what is the distribution later. Now you should know the result of this rand, it will be value between 0 and 1 inside this interval. This is not probability, this is the value of this experiment. So if you just run rand, for example 1 1, this will give us one number of a random value, like here. Okay, we get 0.9501. If we want, we can at one time get like 3 and 5 here. That means we get 15 numbers. They are arranged in a matrix way. You see, we have a matrix of numbers. Totally, we have 3 rows and 5 columns. Yes, 3 rows, 5 columns of random values. Right. So this rand is a built-in function of MATLAB, which will provide us random values. The values are between 0 and 1. 0 to 1. If you want to have some random value between like 10, 0 to 10, you just times 10 on it. You get values between 0 and 10. Right? If you want to have some values like from -5 to +5, this way. Now I have random values between -5 to +5. And now I have 3 and 5, 3 rows, 5, totally 15 numbers. If I want 40 numbers and arrange them in a 4 times 5 square, or 4 times 5 matrix, then use this command. So you can, you can have all different kind of like 6 times 5, and there's 30 different values. So this is very convenient. If you want to do some experiment, you want to check some random things, and by this random function, it can give you just in one time give you a lot of random values, not just single random values. It can give you a lot just in one command. One command you have a lot of random values. And for this rand, you can think this is an experiment. For this experiment, you can see some event. For example, you want to see like something smaller than 6. You can check this one. Oh, not 6. This is between 0 and between 0 and 10. I want to check whether this is more 6. Use this command. This is what? This is here give us some random value, then times 10. So the random values between 0 and 10. And less than 6, this is kind of a logic operation, and the result will be true or fail. Right? It is true or it is fail. That 0 is fail and 1 is true. So like I run this, I will get some 0 and 1. You see, some 0 and 1. That 1 means you really get the result. It is smaller than 6. And 0 that means you get a result that is larger than 6, not smaller than, not maybe equal to 6. Okay. So this result is some, use smaller than 6 as a standard. Then you have 2 different events. Smaller than 6, that event happened. Larger than 6, that event didn't happen. And the result is here. Then you can take the amount of them. For example, I use a sum. Sum means summation. Summation of these will give us totally how many 1 inside this result. That means how many event, how many happened for how many times. Totally we have 30 samples, right? We do the experiment 30 times, and each time maybe smaller than 6 or larger than 6. I want to know how many times the result is smaller than 6. The result is smaller than 6. Oh no, I need this is column. Okay, I use this one. I use 30. 30 times 1. 30 times 1. This is a column vector. This is a column vector with 3 elements in one column. And how many of them they are smaller than 6? 19. So the probability will be this one out of 13, right? Out of 30. Out of 30. This is the percentage of this event happen. I get 0.667. Can we try more? You see, different time you get different result. Every time I repeat this experiment 30 times, and I get the rate smaller than 6. I perform these 3 times. Each time I get different result. each one will be approximate to the probability, but 30 samples is too less. I can try like 3,000 over 3,000. We do 3,000 experiment, and we can see how many times we get a number smaller than get a rate smaller than 6. 5A, 5.59, 0.58. You see, this when we have 3,000 samples, this rate is quite close, around 6, around 0.6, right? Around 0.6 every time. I take 3,000 samples, and then we have around 60% certified condition smaller than 6, right? So we can see the probability of this event. This is the event, right? Is about like a 0.6. It's an estimate. If you try more, then you can have better estimation. This one, yeah, more close to 0.6, right? More close to 0.6. Yeah. All right. That's all for today. See you next time. Next time will be on Wednesday, right?